So yeah, hello everyone. So welcome to week 4 lecture live session by me. So how many of you watched all the lectures of week 4 just for the query? How many of you watch? Am I audible? Oh, that's great. What about Heeraj? Lakshmi, Bhavna?
No, I haven't watched.
You also have watched till week 4?
No, I haven't watched.
Okay, you haven't. Okay. Bhavna?
I've watched the lectures, 3 lectures.
Week 3 or 3 only?
No, fourth week lecture.
Okay. So basically, I'll start. I'm just waiting for some more people to join. Only 4 people have joined. Let's wait for 2 minutes, then we will start. Basically, week 4 was more of a theoretical perspective. I watched it today only, so I'll just go through it little. Like previous weeks, I'll not go very deeply. But yeah, and then we will solve the problems. In this week, basically, sir taught about the decomposition things like LU decomposition and QR decomposition, and then why he taught, because he was telling the number of flops required for calculating an inverse of a matrix is very much, is very high. So in order to simplify it, we can go to lower triangular matrix and upper triangular matrix, and it's just to solve it properly. The motto of this week. So this week was little, like, it was very easy and somewhat complicated also. So yeah, I don't think people are not joining. And two other guys are also here. Rishabh and I think only 3 people. 4. Okay, so I'm continuing with the 4 people that you have joined. Thank you for joining. So basically, in first lecture, what is the motto? Like till this point, we have seen in the previous weeks that why we need left inverse and the right inverse, and where the left inverse are used and where the right inverse are used. So left inverse is basically for tall matrix as well as square matrix, right? And right inverse is for the wide matrix. Okay, why wide matrix? Because in the wide matrix you will have more equations and less unknowns, and in that case we saw that in right inverse case there is always a solution, whereas in the left inverse case there is not guaranteed that it will be a solution. It will have the solution. It can have a unique solution, it can have no solution. Okay, but in the right inverse case we saw there will be many solutions, so at least one solution will definitely exist. So that we saw. Then after that we saw that whenever left inverse and right inverse are equal, then that will be a case of square matrix. Okay, and in that case you also have the unique inverses that is existing. Okay, so yeah, from here we will start this week 4. Okay, so we saw left inverse is equals to right inverse for square matrix. Okay, because that was the only common thing. Then after that we saw in this case, if columns are linearly independent, what does this imply? It implies it will have basis vectors, columns will act as a basis vectors, and then it implies inverse exists. Also, one more thing which is very important. This implies there will have a unique solution. Okay, so in case of unique solution, what we saw, suppose A is a square matrix, because most of the time we will be solving system of linear equation, and in that the number of equations and number of unknowns will be equal. So in that case, there is a square matrix. So in that case, you are asked to calculate whether there is a unique solution exists or not. Yeah, Lakshmi. Anything? You raised your hand.
Will this recording be available on the
Yeah,
site
it is available.
of this live session, right? Okay.
Yeah, last session recording is also available. Like I don't know like whether you are able to access the previous recordings or not. Can anyone confirm? Anyone else? Like if you go to Swayam portal, in that there is a last column. If you ask me, I can show that. The last column is live session recordings. In that one sheet is there. There we both TAs are assigned for this course. One is other person. He used to take yesterday, I guess, and then I am taking. So all the recordings, all the this lectures are recorded, and they will be up. These recordings will be uploaded to the YouTube, so that those who want to see it again, they can see. So it will be in the SWAYAM portal itself, the applied linear algebra SWAYAM portal. In that last column, last row, only Saturday. Yeah. So I am also taking weekly ones, like only Saturday. Okay, today is Saturday. Yeah, today is Saturday, and the other person is taking on Friday, every Friday. So 2 live sessions are going every week. That too 2 hour. So are you guys able to access that? Because these live sessions are for you only. So as Guru Swami told that it is only Saturday, I have watched all that. Okay. Can anyone else confirm it? Anuraga? Yeah, here, sir.
So what was the sorry, I missed it.
What?
What you were asking, I missed it. Sorry, what you were asking, I missed it.
Okay, I'm asking whether you are able to access the recordings of the sessions, of the live sessions.
That only 2 weeks I've done. Okay, still not. Last week I haven't done any.
No. Recordings of the live sessions that we TAs are taking.
No.
Okay, so I'm adding in the chat box. Just wait for a while. So you please save this spreadsheet with you, and if you go into this spreadsheet, you will find 2 TA name. My name is there, and other TA name, Sai Krishna name is there. Okay, so if every session, whatever session is taken, that is recorded and it will be uploaded in their YouTube channel. The channel link is also there. You please save it. Okay, so moving ahead, what we were talking about. So yeah, if A is a square matrix, so we saw number of, because most of the time you are asked to calculate the unknowns, the equations, unknowns for certain number of equations. So in that form, you can represent a set of equations in the form of square matrix. So that unknowns we are asked to calculate. That is the biggest problem in every sense. Like in linear algebra, you are asked to do that. So if the number of equations are equal to number of unknowns, so what we call this we can represent as a square matrix, because let's say equations are m and unknowns are n. So matrix will call as a m cross m, and here n is equals to m. Okay, now this is case 1. Let us solve by case 1 and 2. Okay, case 1. So here you can write Ax is equals to b. Okay, this is A is a matrix, x is the number of unknowns. We can write this as, suppose 3x1 plus 4x2 is equals to b1, 2x1 plus 2x2 is equals to b2. So this is 1, this is 2. So the A will be 3, 4, 2, 2, and x will be x1, x2, b will be 1, 2. So here On top of it, if columns of A matrix, okay, are linearly independent. So in the whole lecture, in the whole week, this is only taught. Then we try to solve this equation using some minimal computation, and then we do LU form and then QR decomposition. So if it is linearly independent, then we say A inverse exists, and this implies mod of A is not equal to 0, means determinant of A is not equal to 0. And this, at the same time, if A inverse exists, then unique solution is there. I hope this is clear. Then we will have case 2. Now you will help me in case 2. If number of unknowns is less than number of equations, then what will be the case? What type of matrix it will make? Guruswami, you have watched all the lectures. Tell me. Simple. Let's make it, if this is again AX is equals to B. So here let's say we will have left inverse. So what type of matrix will be there? Tall or wide? Yeah, he's right. Left inverse will be there. Tall. Okay. So why tall? Because here you will have 2x1 plus 3x2, 3x1 plus 4x2 and 5x1 plus 6x2 is equals to 1, 2, 3. So you can say the number of unknowns as only x1 and x2, but the equations you'll have is 3. So this type of system of equations is also called overdetermined system. System of linear equation. And in this type, tall matrix exists. Tall matrix exists. So now how will you solve? Here x equals to A inverse left, B will be solved. Okay, or here you would have x equals to A inverse of B, and here what will be the A inverse? A inverse equals to A inverse left equals to A inverse right. I hope this is clear. Now A inverse left. Now tell me what is the formula for A inverse left? Guruswami will tell. Anyone else? Maisa, Anuraga, Ajay, Neeraj, Bhavna, Lakshmi. So in this way we will see case by case and we will not have any issue with that. What is the formula for calculating left inverse? It was there. Oh, very good. A transpose A. What is that? A transpose A inverse whole root is A transpose. So you are doing this A conjugate something. So I'll tell what is that. So this is actually A transpose A ka whole inverse into A transpose. This is also called pseudo inverse. So whenever we start the linear regression, then pseudo inverse comes into the picture in AI. So linear regression is just a method to classify two set of data by fitting a line. So in that pseudo inverse is used. Okay, so this is also called pseudo inverse. Okay, and whenever you'll have, if A has the elements only real number, then you will definitely do this transpose. Otherwise, you will do Hermitian matrix. This is equals to A Hermitian A more inverse A Hermitian. Okay, so what is Hermitian matrix? The Hermitian matrix will be J is replaced by J minus J and transpose of A. When it will be the case when it has some complex values. Otherwise, if it is real, then A transpose A whole inverse A transpose will work. Now, what is the AX value? So, X value from equation 1 is there. This A transpose A inverse A transpose B. Okay. Now, in the previous case, we saw there will be a unique solution. Okay. But what will be the case for here? So it has two cases. It can have no solution or unique solution again. So whenever you try to solve it, and it can have no solution as well as or unique solution. Okay, because anyway, here the system of linear equation might not be able to satisfy the values of x1 and x2 might not be able to satisfy. They may be the case they will not satisfy all the three equations, but there may be the case that the x1 x2 values will be satisfying all the equations. Okay, whenever we say there is no equation, then we try to approximate the value by calculating the error, and that error thing is perpendicular to the plane of these two x1 and x2, and in that case we solve as a we try to find the approximate value because there is no solution existing. So okay, so here you will have two options. Now what is the case 3, which is the final case? So those who are preparing for the exam, they can have a table in their room, or they can have case 1, case 2 and case 3, so that you will not have any issue or confusing thing. So case 3, okay, when number of unknowns are greater than number of equations. Okay, so what type of matrix will exist here? This will have wide matrix. Now tell me what type of so again here it will be AX is equals to B. So wide matrix means 2x1 plus 3x2 plus 4x3 is equals to 1. 3x1 plus 5x2 plus 7x3 equals to 2. So here you can see it will have x1, x2, x3, you'll have 2, 3, 4, 3, 5, 7, and here you'll have 1 and 2. Okay. Now, wide matrix exists. Now, in that case, x equals to A inverse right B. Okay. This is right inverse. I'll tell why right and why left in that case. I'll ask you only. Okay. So yeah, what is the formula for right inverse? What is the formula for right inverse? No one know? A transpose का whole inverse. Yeah. So A inverse right is nothing but A transpose into A transpose inverse into B. So this is the formula for it. So yeah, why in case 3 there is a right matrix, and why in case of 2 there is a left inverse. right inverse and left inverse. What is the reason behind right inverse and left inverse? Yeah, and one more thing. So what type of solution is existing in case 3? You see the system of equations, just think in your mind like what type of solution it be there. So I'm giving you 3 options. First option is no solution. Second is unique solution. Third is solution. Or fourth is infinite many solution. Multiple solutions. Yeah, very nice. So Guruswami is correct. Multiple solution. You can just see by the equations. See, you will have 2 equations and 3 unknowns. Means you can assume any value of x3 and you can have x1, x2 by solving. You can put any value of x3 and you can solve then x1 and x2 for these 2 equations. Or else you can have any value of x1 and you can solve for x2 and x3. Similarly, you can have any value for x2, solve for x1 and x3. So in this way, you'll have so many solutions. So right inverse gives you so many solutions, or infinitely many solutions. Okay, so here you're having infinitely many solutions. Okay, so last question in this case is why in case of case 3 we are calculating right inverse and why in case of case 2 we are calculating left inverse. So I just want to answer from anyone else. Ajay, Maisa is just new to my class. Hiraj, Bhavna, you all were there in the last class. I can expect the same answers from you. Columns are linearly dependent. In case of case 3. Okay, so yeah, we can see in case of case 3 you have columns are linearly dependent, whereas in case of case 2 the columns are linearly independent. Okay, it is for sure the columns are linearly independent, then only the top matrix condition will arrive. So for case 2 the condition, required condition is, I take in this one, required condition. This is very important. Columns of matrix A should be linearly independent. Similarly, the condition for case 2, case 3, required condition, rows of matrix A should be linearly independent. Also, one more side, like you can see A, if A inverse left is left inverse of A, then A inverse right is right inverse of what will be here? A transpose. You can see from here A inverse left is equals to I. This implies A transpose. Sorry, if it is the case, this is A left only. Yeah, so A inverse left is equals to A I, then A inverse right A transpose equals to I. So these are all from the previous classes, and this was very, very confusing and important also. So I tried to write in the form of cases. 3 cases are there. When there will be unique and different solution, you just please try to remember. I'll put the notes in that spreadsheet that I shared. Okay. So in the lecture starts with this one only, like when you will have the inverse is existing, and then the third proves this, that y ka whole inverse is equals to y inverse into x inverse by contrary. Like for example, if you see x y multiplication with y inverse into x inverse, then you can write as x into, because this is associative in property, so x will go out and this is equals to I. Okay, so this means that this is the inverse of this one is this, because a into a inverse equals to I. Okay. Okay. So let A be a invertible matrix, then B is this matrix. Then how you can write the inverse of a matrix? So in that case of a square matrix, the inverse exists if it means if and only if the right inverse equals to left inverse. So sir dot this one. Then sir try to tell if we write any matrix in the form of triangular, upper triangular and lower triangular, then we can write like this. Here lower triangular, upper triangular means here lower triangular equals to 0, whereas in upper triangular opposite will be the case. And here if A is either left upper triangular or lower triangular, then the product is also lower triangular. If two lower triangular matrices are there, then the product is also lower triangular. Okay, similarly same for the upper triangular. Okay, also the inverse of a lower triangular matrix is also lower triangular. Also the transpose of a lower triangular matrix is upper triangular. That is very straightforward. Okay, so yes, so try to prove it, like when the columns of A are linearly dependent if and only if. And yeah, so one more property of lower triangular matrix is we can say the columns of matrix A, that lower triangular matrix is only invertible if and only if the values of the diagonal values are not equal to 0. Otherwise, it will not be lower triangular anymore, and it will not be invertible. So yes, so proof. So I'm not going to prove. It's very straightforward also. Like how you can prove whether the columns are independent or not. By proving the columns, we have to check A x1 plus B x2 plus C x3, where x1, x2, x3 are the columns of any matrix. Then it is equals to 0, ax1 plus ax2 plus ax3 equals to 0 if and only if a1 equals to b1 equals to c1 equals to 0. So in that way only you just try to prove it by checking this, taking this as a one column, taking this as a second column, taking the 3 as third column, and then prove it by association. Then you find if it is equal to 0, then a11 should be equal to 0. Then similarly a22 is equal to 0. Then similarly a33 is equal to 0. So that is the only case it will have linearly independent columns for the lower triangular matrix. Now, also if they are independent, then we can tell that it is also causing the basis. It can also form the basis of the matrix. And in that case, the lower triangular matrix is invertible if and only if the diagonal elements are non-zero. Okay, so moving ahead. So in that next was if Ax equals to B, where A is a lower triangular matrix and A is invertible, then this is simple, the solution. And in lower triangular matrix, it is very, very simple. Equations are very, very simple. How you will solve? X1 equals to, by solving this equation, it will be x1 equals to b1 by a11. Then by solving this equation, this is this one. If you got x1, here you put. So what it is causing forward substitution. Okay. So forward substitution for solving the lower triangular matrix. Okay. Now what you're trying to do? Let's calculate the flops required for calculating for getting the number of unknowns in system of lower triangular equations. Tell me how many flops are required? Anyone? Sir taught in the class. Yeah, Guru Swami, you watch all the lectures, right? I don't know. When the class started. Oh, that's great. So number of flops required for this one is order of n square. That is true. And also, in my first class, there were almost 13 to 14 students. Now only 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 students only there. And they joined, around 10 students joined in the class and they left. What is the reason? Like, how many of you paid the fees for exam? Just raise your hand. Just want to know. Okay, Guru Swami has paid. Lakshmi. Okay, Ajay also raised. He does Lakshmi. He does Lakshmi. Okay, are you continuing? Will you continue this course or? Oh, yes, I will. Okay, that's great. So yeah, so what I'm telling is like we should have we have to tell how many students are joining in the class. So at least stay tuned and join the class. This live session is specially for the students who are taking this course. Like those who are having problem, they can interact in a live session directly and they can ask questions. So we are spending time. So I'm just requesting anyone who is old or is taking the class, they can just join the class. If they have watched all the lectures, then they can revise the concepts and they can solve the questions accordingly. Okay. So till now we saw forward substitution will be there for solving system of linear equation in case of lower triangular system. Okay. In case of upper triangular system, how many flops will be there? Same number of flops will be there. Okay. Order of n square. Okay, only 2 students are there. Okay, so special types of system of linear equation, upper triangular or lower triangular, we saw. Then after that, in order to simplify the system of linear equation, we can decompose any matrix in the form of lower matrix and upper triangular matrix. So the lecture, I think lecture 20 was completely based on this. And there are some proofs. We'll not go into it, but yeah, we can write any matrix that should have that should be invertible. You can convert in the form of LU, where L is lower triangular, U is upper triangular. What is the reason, like why we are doing that? The reason behind this, we have to simplify the solution. We have to simplify solution of system of equation. Otherwise, we will not be able to solve it by finding the inverse of a matrix. For example, you have Ax equals to B and x equals to A inverse B. Now, if A is having very, very much higher order, n cross n, where n is very, very high. So in that case, you'll not be able to find the inverse of a matrix. So that's why we try to write any matrix that is invertible. That it means that the inverse exists. We can write that in the form of LU. So this lecture was completely based on it. So how we can write and all, it's there. So why we are doing, it's also there. Why we are doing, I think that should be clear, because see, this L is simple lower triangular matrix and U is a upper triangular matrix. So let's say this is the reason why we are doing. Let's say X is equals to B. So if you are writing A is equals to LU, and by association property, if you keep L as out, then U, let's say Y is equals to UX, then LY is equals to B. Okay, you can easily solve this LY. If you get the Y value, then you can easily solve UX equals to Y. So yeah, this is two-step process, I agree. But yeah, in this case, you're not calculating the inverse of a matrix. So calculating the inverse of a matrix is very complex. What is the formula for calculating the inverse of a matrix? If anyone remembers, can anyone tell me what is inverse of a matrix formula? It is adjoint of A divided by mod of A. Yeah, very nice. So adjoint of A. So this is very complicated if the order is very, very high. So that's why we are trying to write it this way. So what it is doing? It is firstly creating 0 in the first column, then it is creating 0 in the second row, then it is creating 0 in the third row like this. And at the end you will get this L31, L232. These are very simple. If you go into the lecture, you'll understand. Anyway, this is not all important also, so I'm skipping it. If you have any doubt, you can tell me. But yeah, you should understand like how it is going. And also we saw inverse of lower triangular matrix is also lower triangular matrix. Lower triangular matrix multiplication of two lower triangular matrix is also lower triangular matrix. So these properties are used here. So if you are asked to calculate Ax equals to B, and then if you write it this way, then you can calculate this way, Ux and Ly. So that is only forward substitution, or order of n square will be there. I hope you understand why order of n square will be there. So if you did not understand, I'll just quickly brush into it, go into it. That okay, but yeah, why order of n square was there? Here it was there. Okay, in fact, even it is not here, we can solve, no issue. Yeah, so forward substitution, so you can see here you are having lower triangular matrix. So let's see this you're calculating, okay? And you're getting this way here. You're getting A11 x1 is equals to B1. Okay. So how many multiplications you are getting? So in journal, if you write, you can write like this. Okay, you can write like this. So in journal, you are getting I minus 1 multiplications and I additions. So if you sum it to 2I minus 1, this is equal to 2I. Now this I can be any values from 1 to n. So if you sum it, I is equals to 1 to n, 2I, and you take 2 out, then this I is equals to 1 to n. So here sum of natural number n into n plus 1 by 2. So we neglected this one because it is not increasing in same order. This exponential is different. So yeah, this is order of n square. You should be able to calculate these things. Okay. So I hope this up to LU decomposition it is clear. Now we will see some of the properties of orthogonal matrix, and then the same way we can write any matrix, any invertible matrix, means inverse should exist in the form of QR. Okay, Q is in that L is a lower triangular matrix and a U was upper triangular matrix. Similarly, we can also do that for QR. Why QR came even if we had LU? Why QR decomposition came? So in case of LU, the computational cost or the flops are only when we compute Lij. So number of loss here was very less as compared to the previous one. Okay. Here orthogonal matrix. So yeah, in the same way, A can be written as LU, it can be written as QR. L is lower triangular, U is upper triangular, Q is orthogonal, R is upper triangular. Now we will see some of the good properties of orthogonal matrices. Orthogonal matrices are very important. That we represent it by Q. So orthogonal matrix, what it does physically, let's see. If you have a vector here in xy plane, this is x, this is y, and this is a vector. Suppose it is represented as 0 and 0. Now if you rotate it by some angle theta in anti-clockwise direction, remember anti-clockwise. Okay, and we are getting this one. Now this particular vector will be, suppose this is x vector, so it will be qx vector. Okay, so this rotation is driven by a matrix which is called the rotation matrix, and the rotation matrices are in general orthogonal matrices. We call it as Q. Here it is in 2 dimensions, so it will be cos theta minus sin theta. Sin theta, this is cos theta. Okay, this is Q. What are some properties of Q matrix? So ortho matrices are actually rotation matrix in physical systems. What are the properties that this follows? First and the foremost property that it follows is Q transpose Q is equals to Q transpose equals to I. Okay, this is the property of orthogonal matrix. Now, the basic and the foremost thing is columns of Q or orthogonal matrix are linearly independent. So what does it mean? Definitely this Q column, suppose Q1, Q2 to Qn, Q1, Q2, Qn are linearly independent. Second, norm of columns of matrix are unity. Means if then it is called orthonormal matrices. Now, these are 2 important properties with this thing, okay? Main property I'm coming into. What are the main properties? As we can see from this figure, what we are trying to do, we are rotating this particular vector to a different vector. So, if you have input as x vector, let's use different color. It's also like black. If I have input as x vector, that then you are getting as output as qx vector. Then you can see if you do norm of here, this is not mod, this is norm. I'm very much confused between norm and mod. It's actually same, but still. The double line shows a norm. Again. So norm of input vector is equals to norm of qx. Norm by default is 2 norm. So what you're trying to do? So here you can see from this figure, we are trying to rotate this vector to a different vector by rotation matrix, rotation angle theta, and the norm means the magnitude of the vector that after rotation and before rotation is same. So that this particular matrix can also be written as Q. This is a LTI system. This is X vector and this is QX vector. So norm is same. Norm is that norm doesn't change even before and after. This is a basic and very, very good property of orthogonal matrix. What is the other property and the last property of orthogonal matrix? Anyone? Anyone would like to tell me the last property of orthogonal matrix? Yes. Preserve angles, can you tell me in the form of equation? So Gulswami is right, as we can see from the figure. So anything you try to visualize it in your mind, so you can see the angle is also same. Anyway, it is rotating. The angle is same. Okay. So what we can write in the form of equation? How can we write that? So we saw norm is same. Angle also is same. How sir wrote? Let's see. Let's see how sir has written. Angle is same. So yeah, Mulli sir has yes. Just give me a second, I'll just tell you. Yes. What does this mean, angle? Yeah, so Goswami has correctly pointed. This is third and very, very important property. It preserves the angle. What does this mean? Suppose you have x and y vector and you're converting into qx and qy. So if you calculate the inner product of x and y, so it is same as inner product of qx, qy. What does this mean, inner product? So cos theta, which is nothing but x transpose y divided by mod of x into mod of y, here is equals to, this is also one of the vectors, qy divided by mod of qx, mod of qy, this is qy. This means that x transpose y is equals to x transpose qy. So this is nothing but inner product of xy is equals to inner product of qx, qy. So preserves angle means inner product remains same, and what else? Norm is same. Okay. So from we can see from the figure also we can see that. Okay. I hope this is clear to everyone. If anyone has doubt, please let me know. And I don't know why people are going and coming, going and coming. He has also left. Okay, only we have 3 people. That is fine, but it doesn't give me motivation. Yeah, there is also feedback form that is circulated to all of you. I'm just requesting you to put your feedback there. Like if you want the lectures to be in particular way, we will conduct in that way only. So okay, we saw we can write in the form of value, we can write in the form of QR. Now let's go to the questions directly, because here in the last lecture sir taught like how the rotators can be written in the form of 3D, in the form of 2D, and why QR decomposition is there. The reasons are there directly in the form of lecture. You can just watch that lecture. It's very straightforward and good. So the proof is only there. If you have any doubt, I will go through it. But yeah, it will be again a time waste. Yeah, the basic things I told, that will be enough for solving the problems. Okay, let's solve this problem. Yes, Ajay, Lakshmi, and Guruswami. How to solve this problem? Let's solve. Let A is equals to QR be a QR factorization of A, where A is this matrix. Which of the following corresponds to matrix Q? What should be the answer? Take your time. Any idea, any clue? Through grams.
Use Gram-Smith optimization.
Okay. Answer is D. How to use Gram-Smith? Can you tell me? A transpose A. I think sir didn't taught about Gram-Smith in the class. Guru Swami? Orthonormal vector. Okay. That's great. So according to you, what should be the answer? So I'm telling the answer is not D. At least guess. Okay, take one time and guess. So what is the answer then, Guruswami? 0, 0. What you're telling? 0, 0. Not able to understand it. At least A, B, C something tell them. 0, 0, 1. Okay. Answer is B. Okay. Yeah, so answer is B. Now tell how did you find it? Guruswami, how did you find it? Sorry, my camera got off. So yeah, Lakshmi, thank you for your grants-made organization. That is great. That is also one of the way. But yeah, I think sir didn't taught about grants in the class till now. I guess so. So we have to find first. It's okay. Guruswami is telling only that answer is D. Did sir taught about grants-made in the class? He didn't taught, right? How did you calculate it? He didn't taught, right? Yeah, yeah, yeah. That's what I was waiting. It's okay. So one of the ways Graham Smith, I think I'll deal this question in the next class because then I'll teach you first how Graham Smith works. This is from the week. It should be in the week 5. Yeah, Graham Smith. I know that is a process to find. I think he didn't taught then. Yeah, fine process. Here we try to calculate orthogonal vectors one by one, and using the inner product we try to remove it. I remember that case. But yeah, we will deal this question week 5, don't worry. But one more thing, how to check. First of all, the column should be linearly independent. Okay. If the columns are linearly independent, then we can check. I hope that A and C should not follow the linearly independent case. It should follow only this one. And as Guruswami told, the answer is right. Okay. Moving to the next question. Huh. Tell me the answer for this question. Let's solve. LU decomposition sir taught in the class. Okay, that's great. C. So let's wait for Ajay if he tells. Okay. Okay, Ajay is telling A and Guruswami is telling C. Okay. So I just want to know what is your approach. Ajay, what is your approach? Just type in the chat box. Okay, Ajay is not telling. Guruswami, can you tell me what is your approach? How did you find? See, so let's see the answer. Answer is A. So you are wrong here. Ajay is correct. Ajay, can you tell me what is your approach? Ajay, just type in the chat box. Answer is 1, 2, 4, 5, and try very much. First, we have to multiply lower triangle matrix to A. That checking only, right? But is there any way to just get the exact answer? Yeah, you're checking, right? Multiplier. So if I multiply with 1 by 2, 1 by 4, 0, 1, 1 by 2, 0, 0, 1. So this one is 16 plus 2 plus 1 by 4, 0, 1, 1 by 2. First we have to eliminate 8 to 1, then 8 to 2, and then 8, 3, 2. Yeah, that is a process that is told by sir in the class. Yeah, so it's correct only. We have to first remove this one, then this one, 8, 2, 1, 8, this is 8, 2, 2, then 8, 3, 2, this is 3, 2. No, I think we have to first eliminate this one, then this one, then this one, this one, this one, this one. Like that, you have to eliminate. Okay, I will check. I don't remember the exact formula for that. But yeah, the answer is A. We will again see this question in the last class. So yeah, what is the answer for this? Let A be a arc M cross N, have a linearly independent columns, and if A is QR with a QR factorization, which of the following statements are true? So the columns of Q forms an orthonormal set and diagonal entries of R are strictly negative. No, this is not correct. The columns of Q forms an orthogonal set and R is an upper triangular matrix. This is correct. The columns of R forms an orthogonal set and the diagonal entries of Q are strictly positive. It is not like that we only have PSD matrix. This is not correct. So none of this is not the answer. So answer is B. Yes, as Guru Swami told. No. Okay, so sorry. Yes. Tell me the answer for fourth question. So only one answer. Okay. So Ambili told. Ambili, you are joining very, very late. Like 1 hour already left. And Guruswami is also telling the answer. So okay, let's see this question. If A is QR decomposition and is a QR decomposition of matrix A, then A inverse is definitely R inverse Q inverse Q, because Q inverse is nothing but Yeah, so one property left. Like we saw Q transpose Q is equals to Q, Q transpose is equals to I. So this implies that Q inverse equals to Q transpose in case of orthogonal matrix. Yeah, so this is correct only. So for any B belongs to R power n, there exists X such that AX is equals to B. Yeah, obviously we are trying to solve this because this is an invertible matrix. Then this is existing. So C is, if A is equals to QR, this is QR decomposition of matrix A, then Q matrix is orthogonal matrix. That is correct only. Okay, so all the answers are correct. So answer is D. Okay. Yeah, again it is from QR decomposition. Not sure how to solve this question. But yeah, if any one of you know, let us solve this question. So answer is C, only one told. Let's wait for Ajay and Ambini. What? Your voice is very, very noisy.
No idea.
Okay. Let's wait for Ajay. No, I think that, okay. So, again, the two different logic is there. I'm also not sure how to solve this question. Can anyone tell me? Let us solve this question. Let us see first answer. Answer is C. So, Guruswami is correct. How did you approach this problem? Ajay is telling B, but any like both of you are doing something. Tell me how you are doing. How will I do? I will just check with the uh, Q and R, like how to calculate Q and R. I will try like this. P is equals to QR because sir didn't thought about, oh yeah, orthonormal vector. Okay. Once sir taught about Gram-Smith, then it's very easy to get Q. I don't know without it how will we get. I think you are using Gram-Smith criteria only. But the easy way to check is P is equals to QR. So this should be upper triangular for sure. Okay. So this is not upper triangular, this is upper triangular, this is upper triangular. Now we have to check these two. Okay, orthonormal vectors should be there. Ma'am, you try to Gram-Smith. Okay. Gram-Smith, like we have to first check how Gram-Smith works. Like sir didn't taught in week 4. So I think yeah, we can solve this question after understanding Gram-Smith processor. It's just a processor to calculate the set of orthonormal vectors. And through the set of orthonormal vectors, we can calculate anyway. So for example, here we can see this 1 by root 2 and this, if we check, The answer is C. Okay. So if we see, this is 2 by root 2. This is 0, 0. This is 1 root 3 by root 2. This is 0. This is minus 1 by root 2. This is root 3 by root 2. This is 1. Okay. So I think this is not orthonormal. This is also not orthonormal. This is also not orthonormal. But yeah, one thing I can see. Okay, so this question I'll deal in the next class. A is not upper triangular matrix. Okay, A is not upper triangular matrix. So yeah, the answer will be definitely this one. Okay, so since in QR decomposition P is equals to QR, this should be what? This should be orthogonal and this should be upper triangular. Okay. Okay, I think I have taken some of the question that is not related to this week.
Yes, some questions were somewhat confusing.
Yeah. Okay.
Yesterday, actually, sir told about some law and all, but I got confused
Yeah.
while that. So,
Yeah. It's okay. We will see how to solve this Q and R and L and U. That don't worry. Even this not class that we can solve using glass, but we can definitely solve that. We can try through rotation matrix, but here non-rectangular matrix. Yeah. This is non-rectangular. Yeah, you can solve using rotation matrix also. So okay, we will see how to solve. Let's see. Let's wait for the next week. But yeah, let's solve this question. This is easy. So answer is C. So Guruswami told C. Let's wait for others. So okay, as per Guruswami and Ambili, the answer is C. Let us solve this problem. So which of the following statements is or are true? We have to solve. So the first option is if the columns of A belonging to R M cross N are linearly independent, then A transpose A is invertible. This is what? This is for sure it is true. How? We saw this vector is also invertible because this means that it is A is square matrix. So in that case, this things exist. Or square matrix or tall matrix also. It can be tall. Are you getting the point that how it is tall and square? Even if this tall matrix A is just a tall, not number of rows equals to number of columns, then in that case also A transpose A exists. Okay, so in that A transpose A is if they exist, then it should be invertible. For sure, it is correct. I think nobody have problem. If anyone have problem, just let me know. So this is correct. Okay. So answer number the option number 2. For A belongs to R power m, if A square 0 implies A should be 0. Is it true or not? It is not true. There can be many examples. Okay, so option number 3. Wait a second. I will ask what it is. Okay, so what I was saying, yeah. Option number 3. If for A belongs to R power n, if A is invertible, then A may not always be left invertible. It should be always be left invertible. Not should not be there. Okay, it should always be left invertible. As we saw, if it is existing, then A should be either square matrix or tall matrix. Then it should also be not. Without not, it should be correct. Then if A, fourth option, A matrix belongs to R pos M pos N, linearly independent columns, then A can be stored as A is equals to QR and Q is orthogonal and R is upper triangle as we saw from the QR decompositions. Okay, so answer should be 1 and 4. Correct. Both of you correct. Nice. Yes. Let's go to now let us solve this question. So all of you told answer is very nice. Guruswami told D. Ambili is also told D. Okay, so let's see this question. Q belongs to R 2 cross 2 such that it rotates this vector anti-clockwise and identify which of the following denotes the given operation is. Oh, obviously the answer is D. Cos theta minus sin theta. This is very straightforward. Okay, let us solve this question. Okay, let's solve this question. So it is very similar to LU decomposition again. But we have to make sure I'll definitely give you some tricks to how to solve this LU decomposition and QR decomposition. I'm also getting confused because that was not very clear in the videos. But still, if you have any suggestion or a guess, let me know. So we can see all the 4 options are upper triangular.
Please explain how to solve it.
Really, your voice is very noisy. I couldn't hear anything. Can you please type in the chat box if possible? Please explain how to solve this. I will explain this after Grant-Smith processor. I mean, just wait for a while. Like next week, I can explain these 3 questions. So I'm also not sure of the trick. Yeah. Anyone like who know Guruswami? Because I today only I watched all the lectures of week 4. I didn't get most of the things. But yeah, I will try to find this how to solve this LU and L. But because there can be many options, but he taught some different ways. This 3 2 2 1. If you watch a lecture, you can solve. Okay, I watched a lecture, but I couldn't get that very clearly. But yeah, I will try again. Maybe I watched very fast. Okay, so can you tell like how to solve? Okay, so these two questions I am keeping on hold. I will solve this for sure. I will solve in the next class. In the beginning only, I'll solve in the next class. Maybe I watched very fast, but yeah, there are some tricks. In QR decomposition that can be solved by Gram-Smith criteria, so don't worry about it. But yeah, this LU is still in confusion. Like the aim is to keep it this one 0, this one 0, then this one 0, and this one 0. Then we are trying to make it as L inverse here A. Then this L inverse is nothing but L transpose. Something was there. Okay, so moving to the next question. So again, this is related to Gram matrix. So Gram matrix is nothing but A transpose A. So it has linearly independent columns and K is this one. The Gram matrix of A is denoted by this one, and the Gram matrix of R is denoted by N. What is the relationship between M and N? So R transpose R. So you are asked to find the relation between M. This is N. So this should not be equal. What is the relationship between what you are giving? Answer for the previous question. So you are giving 1 0 0. If you multiply the output, you will get the upper triangle matrix. So what is a funda? Can you please tell us in the class now by making your mic unmute?
First, you would eliminate 8 to 1.
Your voice is so slow. Please tell.
First, you have to,
Yeah, Guru Sahib.
first, you have to eliminate 8 to 1.
Yeah, first you have to get.
Eliminate 8 to 1. 8 to 1 to 0.
Wait. His voice is not clear. Can anyone else confirm? Ambili, can you please confirm? Can you speak a little louder?
First, we have to eliminate 8 to 1 to 0.
A212 0. Okay, this one.
For that, what we have to do, first you have to multiply 100 minus of 10
Okay,
minus of 10.
minus of 10.
Next row, minus 1 by 2,
Okay,
10.
okay. So you are calculating L21, then L uh, th- 22,
L31,
like that, right? Okay.
L21, L31, and L32.
Okay. This one. No, this one, then this one.
No, only 3 element only. L21, L31, L32. That's all. Only you have 3 element only you have to eliminate. Then it will automatically come up the triangle.
Okay. Okay.
That is the procedure. So are also taught like that
Yeah,
one.
yeah, yeah, sir taught like that. Okay. It was little unclear. So, okay, fine. Nice. So, we will, if we will again go through that lecture, we will get to know.
I already given this matrix in chat box. You can look into that.
Okay. Okay. So, we will solve these three questions in detail in next class. I will again go through that lecture. So, yeah, let A be this matrix, invertible matrix, and A is QR. And if A is this one, then span of this one is equal to this one. The answer is true. Let us understand this. How? Because we are doing that A is equals to QR. So span of invertible matrix means linearly independent columns. So, and if we are equating to a particular different matrix that is also having linearly independent column, that because it is orthogonal. So, yeah, if set of equations are representing any single matrix, then it should be equals to span taken by different this linear independent column. So, yeah, that is true. In QR factorization, we have to make sure that this should be equal. Otherwise, we cannot do that QR factorization itself. Because if we are writing the matrix in the form of orthogonal matrix multiplied by upper triangular matrix. So I think this question is clear. So this question, the answer is M into N. The same fundamental only, because this is a gram matrix. Okay. So when we write A is equals to QR, so it means that span of A is equals to span of Q. So it means that A transpose A is equals to R transpose R. Then only it will be there. What is the relationship between M and N? So gram matrix is N. This one is N. This is M. So yes, if you have any doubt, we will deal in the next class. And I will tell how to solve this QR decomposition and LU decomposition in detail. So, yeah, so if you have any query, just let me know. This is from gram split process, and this questions we solved. Yeah, there are 2-3 questions that is left, so we will again deal that. Okay, still we have time left, but so we will see the theory part once again. So that the 2 last questions were there in the last lecture. So taught like how it is equal. This LU thing, let's see that. So yeah, what we're trying to do here, we're writing A matrix in the form of LU. Now, yes. So let's say L21 is nothing but 1111. Here this is L21. It should not be equal to 0. Choose L21 such that L21 equals to minus of A21 divided by A11. Why? Because we need to make it this as 0. This row. So yeah, here it started. This row we need to make it 0. So yes, so this if we write L21, A11, okay, it should be equals to minus of A21. Why? Because this we need to make it 0. So L21 is equals to minus A21 divided by A11. Okay, this one I got. Then it is making 0. Okay, then let's make it L31. So L31 will be L31 A11. Here it is 0 only. A31. So yeah, L31 is minus A31 divided by A11. Okay. So first L21 plus L31. Similarly, it will go to LAN1. Okay. Okay. So L31, L21, L31. So it will start again L41, LN1. Okay. All these things. It will make this 0. Choose L32 now. This one. First we need to make it 0 here. Then this one. L32 such that L32 plus this will be multiplied A12 plus A32 should be 0. So L32 should be equals to minus A32 divided by A12. I think so. No, it is A22. Why? Because this one is 0 or what? L22. L32. So this one is 0. Okay, okay. So sorry. So it will be L22. Okay, I understood. This one, then this one. So yeah, the L matrix here, this one is L inverse. Okay, these that we are calculating L21, L31, then L32, L41. Okay, then L32, then L42. First we are making, okay, let's see, I'll tell you. First we are making this one as 0, then we are making this one as 0, then we are making this one as 0, then we are making this one as 0. But this all things are L inverse. And you know, the inverse of a lower triangular matrix is itself a lower triangular matrix. So that we have to calculate. I think that value directly should come in that equations. Okay. So similarly, first column 1, then column 2. Continuing this way, this will be L inverse. Okay. And the output that we are getting is U. Okay. So in this way, I think we can directly get L matrix. Okay. We can directly get this L matrix. But how to get U matrix? We have to multiply. If you want to get U matrix, then L inverse A is the answer. I hope, Amelie, you are getting something. But yeah, what we are trying to do. This is a matrix A. Okay. And this is a non-zero value. This is non-zero value. Now what we are trying to do. We are trying to make this values as 0. First, this is what? L. This is what? L21. This is what? L31. This is what? L41. This is what? LN1. Okay. We are trying to make is this L21, L31, L41. Like this. Okay. Now what is this? This is nothing but L. What this is? L21. This is 22. L21, L31, and this L32. Okay. So this is after this. Okay. Okay. So sorry. This one we will 0, make it 0. This will we have to keep. Then this one you have to this 0. Then this we have to make this 0. This we have to make it 0. Okay. Then this we need to make it 0. So sorry for the confusion. This is 32. L32. Then this is, let's make it color different. L33. This is L34. Then this value, okay? This is not this value because we need to consider this upper triangle because this is upper triangle, right? I was considering from this one. So this one. L34. L44. Okay. And how these values will be? L21 is nothing but, what is L21? L21 we saw? This one. minus A21 divided by A11. L31 is minus A31 divided by A11. I hope this is clear. This is very simple. So what we are trying to do, we are creating L matrix. So L inverse is nothing but this matrix. L inverse is nothing but L21, L31, Ln1 up to Ln1. Then this is L32, then L42 up to Ln2. Then multiplied by L43 till Ln3, like this. So if we consider 4 columns, then then it is up to this point. And this is L inverse. And in order to get U inverse, this is L inverse A. Because at the end, you are getting as output as U. I hope this is clear. But yeah, again, we will try to solve using these equations. And now if we go to Jan Smith thing, QR decomposition, how to solve. The similar way only that is there. Okay, QR decomposition. So these are some properties of QR decomposition. So yeah, what we are trying to do, we are trying to make second element as 0. But this will be very easy if we use Gram-Schmidt criteria. Yeah. So if we try to rotate this plane by in ith j xi and xj plane, then it should be cos theta minus sin theta. Sin theta cos theta should be here. So what the rotation matrix is actually doing, it is making first element as the first element, then second element as 0. So this is what Q21 is cos theta 1 minus sin theta 1. Okay, this thing we will deal in the next class. I think also getting tired. Okay, so if any doubt, you can tell. Otherwise, we will end the class today with this. Don't worry, we will solve the questions related to LU and QR decomposition. I got the idea in LU, and similarly, the same things will be there in QR decomposition. But yeah, I will again tell the some trick using Gram-Schmidt criteria. Okay, thank you so much for joining. Thanks, Billy.